It is an absolute necessity for immediate physiological safety. Acute fluctuations in blood glucose, both dangerously low levels, hypoglycemia, and excessively high levels, hyperglycemia, can lead to severe, life-threatening crises, demanding swift and precise nutritional intervention. The inquiry into which dietary elements facilitate the quickest and most effective blood glucose stabilization touches upon the complex dynamics of nutrient absorption, insulin signaling, and metabolic response. While managing hypoglycemia requires an immediate infusion of easily absorbed carbohydrates, controlling hyperglycemia necessitates a strategy focused on dampening the speed of glucose absorption and enhancing the body's sensitivity and response to circulating insulin. This comprehensive exposition will delve deeply into the 5 primary food categories and nutritional principles that form the foundation of acute and sustained glycemic control, providing a thorough, evidence-based understanding of how specific dietary choices can serve as powerful tools for stabilizing blood sugar and supporting overall metabolic health. The mechanism of stabilization: controlling the rate of glucose. Influx, effective glycemic control is fundamentally achieved by manipulating the rate at which glucose enters the bloodstream from the digestive tract. Foods that are rapidly digested and absorbed lead to sharp, detrimental spikes in blood glucose, placing immense strain on the insulin-producing capacity of the pancreas. Conversely, foods that slow the digestive process provide a gentle, prolonged release of glucose, allowing the body's insulin system adequate time to process and clear the circulating sugar. Dietary focus: consumption of dark leafy green vegetables, such as spinach and kale, broccoli, and pumpkin seeds ensures a rich supply of magnesium to support the body's internal glucose processing machinery. B. Chromium, the insulin potentiator. Chromium is a trace element that is thought to enhance the downstream signaling effects of insulin. It acts as an insulin potentiator, effectively making the body's naturally produced insulin more efficient and potent at clearing glucose from the bloodstream. Glucose tolerance factor. Chromium is a component of a molecule known as the glucose tolerance factor, GTF, which is believed to regulate the binding of insulin to its receptor sites. Sources: foods rich in chromium often overlap with magnesium sources, including whole grains, green vegetables, and specific seeds. Prioritizing these foods provides the necessary micronutrient foundation for optimized insulin function. 5. Managing carbohydrate intake. Prioritizing natural sweeteners and low glycemic load. For individuals aiming to stabilize blood sugar, the type, quantity, and preparation of carbohydrates are the most critical variables. The focus must shift away from refined, rapidly digestible carbohydrates and towards sources that provide a balanced energy release. A. Whole fruits over refined sugars. When the body requires carbohydrate energy, whole fruits offer a vastly superior alternative to processed foods and added sugars. Fiber-contained sugars, the natural sugars, fructose and glucose, in fruits like apples, oranges, pears, and berries, are encapsulated within a complex matrix of fiber. This fiber slows the enzymatic breakdown and absorption of the sugars, resulting in a gentle, prolonged energy curve rather than a disruptive spike. Nutrient density. Furthermore, fruits provide essential vitamins, minerals, and antioxidants that support metabolic health, a benefit completely absent in refined sugars. They contribute to sustained energy without the inflammatory burden associated with glucose overload. B. The danger of added sugars. Conversely, foods containing high amounts of added or refined sugars, such as baked goods, sodas, and candies, lack fiber and other mitigating nutrients. They lead to an immediate, massive surge in blood glucose, triggering an acute stress response from the pancreas and exacerbating insulin resistance. Strict avoidance of these items is non-negotiable for effective glycemic control. 6. Conclusion: the holistic prescription for glycemic stability. Achieving the quickest and most sustainable stabilization of blood glucose is an integrative process rooted in conscious dietary choices rather than the consumption of a single magic food. The foundational strategy involves a symbiotic combination of macronutrients and micronutrients working in concert to manage both the speed of glucose entry and the efficiency of glucose clearance. The prescription for rapid glycemic stability relies heavily on the mechanical resistance of soluble fiber, from oats and legumes, to flatten absorption curves, the metabolic support of lean protein, from fish, poultry, and soy, to enhance satiety and preserve glucose-consuming muscle mass, the catalytic action of magnesium and chromium, from dark greens and seeds, Optimizes cellular response to insulin. The balanced energy delivery of whole fruits, fiber-rich berries and apples, manages necessary carbohydrate intake safely. By committing to a diet rigorously structured around these principles, individuals gain immediate, powerful control over their acute blood glucose fluctuations, thereby minimizing daily symptoms, reducing reliance on corrective measures, and profoundly improving their long-term health trajectory and quality of life. This dietary commitment is the most consistent and effective form of acute metabolic intervention available. A. The paramount role of soluble fiber in modulating absorption. Dietary fiber, particularly the soluble variety, is arguably the most critical component for acute blood glucose management. Soluble fiber dissolves in the watery environment of the digestive tract to form a thick, viscous gel. Physical barrier formation. This gel acts as a physical barrier within the small intestine, literally slowing the movement of chyme, partially digested food, and the contact of digestive enzymes with carbohydrates. This physical mechanism translates directly into a significantly delayed and prolonged absorption of glucose, effectively flattening the post-meal glucose curve. Reduction of post-meal spikes. By preventing the rapid influx of sugar, soluble fiber dramatically reduces the severity of postprandial hyperglycemia, which is often the most challenging aspect of diabetic management. Sources of efficacy. To harness this effect, nutritional focus should be placed heavily on foods such as oatmeal and other whole grains, various types of legumes, including lentils and peas, and certain vegetables like broccoli and celery. Consistent daily consumption of these items provides the mechanical resistance necessary for smooth glycemic control. B. The supporting role of insoluble fiber. Insoluble fiber, while not forming a gel, adds bulk to the stool and accelerates transit time, promoting overall digestive health. A healthy, efficient gastrointestinal tract is foundational to consistent nutrient metabolism, indirectly contributing to better glycemic regulation by maintaining a balanced environment for nutrient absorption. Integrating whole grains, nuts, and the skins of fruits and vegetables ensures a steady intake of both types of fiber for comprehensive digestive and metabolic support. 3. Protein and satiety, maintaining metabolic equilibrium. Protein is a cornerstone of a blood sugar stabilizing diet because, unlike carbohydrates, it exerts a minimal direct influence on immediate blood glucose levels. Its primary contribution to glycemic control is through two vital mechanisms: promoting sustained satiety and supporting the body's most active metabolic tissues. A. Sustained satiety and caloric control. Protein digestion is a relatively slow and complex process, making protein-rich foods highly effective at inducing and sustaining feelings of satiety. This prolonged fullness is crucial because it helps individuals manage overall caloric intake, control portion sizes, and resist the temptation of high glycemic snacks between meals. By anchoring meals with quality protein, the risk of overconsumption, which invariably leads to glucose spikes, is mitigated. B. Muscle mass and glucose clearance. The body's skeletal muscle tissue is the primary site for insulin-mediated glucose uptake and utilization. Therefore, maintaining and building lean muscle mass is fundamentally linked to improved long-term glucose disposal and enhanced insulin sensitivity. Plant-based sources. Excellent plant-based proteins, such as tofu, almonds, chia seeds, and various seeds, offer a concentrated dose of amino acids alongside healthy fats and fiber, providing comprehensive metabolic support without the saturated fat load of some animal products. Lean animal sources. Prioritizing lean animal proteins, particularly fish and white meat poultry, when consumed without the skin, supplies the essential amino acids needed for muscle repair and maintenance. Fish in particular offers the added benefit of omega-3 fatty acids, which possess powerful anti-inflammatory properties known to improve cellular responses to insulin. The deliberate inclusion of sufficient, high-quality protein in every meal helps stabilize blood sugar by providing structural building blocks and suppressing the hormonal drives that encourage excess caloric intake. 4. Micronutrient enhancement, boosting insulin sensitivity. While macronutrients control the volume and speed of glucose delivery, certain trace minerals act as essential cofactors that directly enhance the efficiency of the body's glucose disposal system. The insulin signaling pathway. Focusing on foods rich in these minerals can optimize the body's response to the insulin it produces. A. Magnesium. The enzyme activator. Magnesium is an indispensable mineral involved in hundreds of enzymatic reactions, many of which are directly related to glucose metabolism and insulin action. Cellular sensitivity. Magnesium is necessary for the proper functioning of insulin receptors on cell surfaces. Deficiencies are often correlated with increased insulin resistance, a central feature of type 2 diabetes. Energy production. It is also vital for the process of converting glucose into energy.